Alright, ready for a restricted sweep. 6 coming aft. Full aft high force. Forward. Full forward high force. 6 coming left. Full left restricted. 6 coming right. Full right restricted. Pedals coming left. Full left restricted. Pedals coming right. Full right restricted. Yaw limiter high, roll ratio high, keep fuel low. Cautions are clear, pointers are moving. Pointers are correct, ready for a full sweep. 6 coming aft. There's full aft full. Low force rather. Neutral coming forward. Full forward, low force. 6 coming left. Full left, full. Neutral, 6 coming right. Full right, full. Pedals coming left. Full left, full. Pedals coming right. Full right, full. Stick pullers coming out. And release in 3, 2, 1. Mark. Alright, looks like a good stick puller. Limiter knob, auto, roll ratio, auto, Q fuel, auto. Pointers are correct, cautions clear. Gives trim. Alright, trim looks good. FCS interrupt. Alright, all 4 cautions and all 3 advisories. Trim doesn't move. FCS interrupt undepressed. Cautions are clear. Trim set 11.9 up 0 and 0.1 right with green boxes. Transfer knob forward commanded, bottom commanded, aft commanded, mid commanded, back to auto with forward commanded. Our full 120-2 is selected. Start 4 in 65, duration 120.
Test control profile is confirmed and you are go. Fez start stop button push.
Copy, Fez is armed and braking gauge is clear. Here comes the Fez start stop button. Fez is moving. And Fez stopped. are coming out. Gas inventory is clear, and you're going to remove the Bluetooth headset. Removed and door is closed. Got a good comm check with Chase 1 and 2. You guys still up? Chase 2 is up already. Hold this step 69 shocks.
Test control, you are go to remove chocks and for the taxi checklist.
Chocks are coming out. Chocks are removed. Chase 2 ready for taxi.
Welcome everyone, wherever you are in the world. Good morning, good afternoon, or good evening. Here we are at the MOJAVE Air and Spaceport. Thank you so much for joining us. My name's Mike Bannister. I was formerly British Airways Chief Pilot for Concorde, flying supersonic aircraft at Mach 2, twice the speed of sound, for 22 years. And I'm delighted to be here today for Boom Supersonic at this really historic moment when the XB-1 goes faster than the speed of sound for the very first time. It'll be the first civil aircraft to break the sound barrier since Concorde. And I'm joined here today by my good friend Greg Crowland and also by my other good friend Nick Sharika, who's down on the fence line. But Greg, over to you.
Hi, thank you, Mike. Yeah, my name is Greg Crowland. I was Boom's chief engineer for the XB-1 aircraft during much of its design, build, and test phases. So I'm incredibly excited to be here with you today, share some insights about the aircraft and the mission that we're going to perform. And the mission today is a big one. XB-1 is the first independently developed supersonic jet. And today is the day that we're going to go supersonic for the first time on this aircraft. The plan is to accelerate the plane to Mach 1.1, about 10% faster than the speed of sound. I'm now going to throw it down to Nick Sharika, down at the fence line, to see the aircraft.
Hey there, my name is Nick Sharika. I'm the Chief Flight Test Engineer for Boom Supersonic. That means I've been involved in planning all of the XB-1's testing up to this point. Today is XB-1's 12th flight. We've previously expanded the entire subsonic envelope. And I see XB-1 taxiing behind me right now. Let's just get a look at XB-1 taxiing out.
squawk in 0111.
They are, Greg. Doesn't she look gorgeous taxiing out?
Checks complete.
Yeah, absolutely. I want to point out here that so today in the airplane we have Tristan Geppetto Brandenburg. He's a former naval test pilot. Obviously was an operational pilot for a long period of time. Has a tremendous amount of experience flying both fast jets and doing flight test programs. This is an extremely, I would just say, this is an extremely specialized position and requires, you know, a very specific set of skills that he has. He's being joined by 2 chase planes today. We've got a Mirage F1 that is being flown by AJ Face McFarland. Face is the call sign there. And then we also have a Northrop T-38 that's also out there being flown by Matteo Brambilla, who goes by call sign Wiper. Those 2 planes are in accompanying XB-1 along the majority of the flight and serve a number of functions. But you can see them here, all 3 of them in line, heading down to the whole chort.
And what's going through the pilot's mind as they taxi out? Well, of course, especially today, an exciting day, the human instincts, that excitement, responsibility, a bit of nervousness, but a pilot places all of those at the back of their mind. It is all about safety, the mission, the test objectives, and that big team behind us being very precise, patient, and professional. Nick, can you tell us all about those chase planes that you can see down there?
Yeah, sure. So as Greg alluded to, the first aircraft there is a Mirage F1, and that's serving the role of primary safety chase today. What that role is just an airborne set of eyes and additional situational awareness to the test team. The pilot, Geppetto, he can offload tasks to the chase aircraft, like managing the airspace and talking to air traffic control, so that he can stay focused on the mission and the test points that we'll be executing today. The T-38 is serving another role as photo chase today, and if technology plays with us very well, then we'll have some really gorgeous shots of this whole mission live.
As we're listening to the control room and the pilot chatter, there's a lot of communication going on between the pilot, Geppetto, and the control room back here at base. And what's all that about? What are they talking about at this stage, and what's the role of the control room during the flight?
Well, flight test really is a team sport, Mike. We've got, of course, Geppetto in the cockpit serving the critical role of test pilot, but also in the control room, we're joined by 25 engineers, and it's their job to review countless amounts of telemetered signals that are beamed from XB-1 live down to the ground. These are what we call safety critical parameters. So as we're expanding the envelope, there's just too much workload for any one pilot to perform in the cockpit alone. And so the control room serves as an extension of the airplane, and all those 25 highly talented engineers reviewing data live and making an assessment that everything is going according to the plan. Leading the control room today is Erin Young. She's serving as the test conductor, and it's her job to kind of filter and aggregate all of that input from the various disciplined engineers in the control room, and she'll be in direct communication with Geppetto throughout the entire mission. Jeff Mabry is serving as our test director today, and his role really is that of coordinating external assets and external support for the mission.
Of course, it's not like an airliner that can just taxi out and wait for clearance and line up and off you go. There's a whole raft of checks still to be taken and undertaken before XB-1 can get airborne. And they're going through that process right now. That shot you saw a few moments ago of the control room looks a little bit like a NASA control room back in the day, with lots and lots of people sitting at their desks. And every one of those individuals and every one of the XB-1 team here has a no vote if they're not comfortable with something that's going on. They certainly speak up. It's a total team game. And that even extends out to being out on the runway. We'll have some ground crew out at the holding point. So Nick, tell us what the role is of the ground crew when they're out at the holding point there with XB-1.
Right, so you saw a lot about how they readied the aircraft before taxiing out. And so the team on the ramp today is being led by Kurt Alger, the crew chief. And they were just eyes on the outside of the airplane as Geppetto performed his startup checks. Now, at this point, they're doing what they call last chance checks. They're at the threshold of the runway, and the team will just do a once-over of the aircraft. They'll do things like inspect the tires to make sure we didn't pick up any rocks or nails or anything like that as we taxi it out. They're just doing a final survey of the aircraft before Geppetto takes XB-1 onto the runway.
And of course, that's normal for ground test and test flight. And we could see that crew chief now walking up towards the airplane. Following the taxi, we'll taxi into position and do some engine run-ups. So, Greg, you're familiar with all of this. How does it look like it's going?
Right now, I mean, it looks like it's going incredibly smoothly. You see there Kurt Alger going around again, getting those final checks on the panels and on the aircraft there. Supporting him is Eddie O'Hare.
Checks are complete.
And we're just getting
Before takeoff checks.
just confirmation
Test
there.
control, your go before takeoff checklist.
Yep, so everything we do is
Warning, caution lights, cast messages are all clear. Canopy is down a lot, panels pull forward. Oxygen's on, 100% normal, masks on, dampers are on, fuel systems are auto. Here comes controls.
So what are we hearing here, Greg?
I want to make sure we're leaving space here to hear what's going on, but everything we do is per a checklist. So from the moment the pilot got into the airplane,
Controls feel good, heights look good.
what we're going through now is per a checklist. It is, you know, standard for every pilot, whether you're a private pilot all the way up to commercial or test pilots.
Trim, I'm showing 12, 0.1 up, 0.1 left, and 0.2 or 0.1 right on the rudder, all in the green boxes.
And what that is those are the trim.
Anti-skids auto, backup high pump auto, transfer knobs auto, FLVS selected, fuel probe.
And what those are the trim settings we heard there. Everything's in the green boxes, making sure that all the control surfaces are in the correct positions for takeoff. You can see at the back end of the airplane there, the horizontal tail is deflected, slightly trailing edge up. That's about 12 degrees trailing edge up is the position for the takeoff trim setting for XB-1. So we just go through all these checks, make sure the airplane is appropriately configured for the mission that we're about to undertake here. And again, he gets the support from the ground team. They have the visual on the exterior, making sure that yes, the trailing edge up indication that we have external, it matches what the pilot is seeing internally as well. As Nick was saying, going over, checking the instruments, checking the tires, etc. He was being supported by Eddie O'Hare, who was out in front. When there is someone underneath the aircraft, the pilot has to go hands up, meaning they don't want to inadvertently move throttles or the controls. That would endanger the person who's underneath the aircraft. So they keep a visual line of sight with another individual. Now, in this case, I believe it was Eddie O'Hare, who was pointing out to the pilot where Kurt was underneath the aircraft as he was inspecting, the components there. So now the next component here in the checklist is make sure that we have, again, all the pins are removed and stowed, and then we're going into the takeoff checklist. So, Nick, you want to tell us a little bit about the mission that we're expected to, and how it's expected to go today?
Yeah, sure, Greg. Thanks. So today, of course, the objective is to safely break the sound barrier. This would be the first time that XB-1 accomplishes that feat. Previously, we've been to Mach 0.95, just 5% shy of the speed of sound. But we're going to do this today in a very special piece of airspace. We're going to take off, and climb to the east, and then turn around westbound and enter what's called the Bell X-1 supersonic corridor. That's a special piece of airspace that's famously named after Chuck Yeager in the first ever supersonic flight of any aircraft back in 1947. We have special permission to perform this mission today from the Federal Aviation Administration. They've given us a special waiver to perform today's supersonic testing. This will be in the United States.
All right, throttles are coming up.
And as they taxi into position, Nick, we can see the two chase aircraft accompanying XB-1. What's the role of the two chase aircraft specifically?
Stable. Idle.
So what we're seeing here right now, Geppetto's actually just doing some engine checks, final verification that everything is within band, within parameters, limits for all the three engines. The two chase aircraft today, they're really just airborne support for Geppetto, helping offload any tasks that are required, keeping eyeballs on the outside of the airplane. If we have something like an oil leak or something, Chase can see it immediately. So the value of having Chase airborne on any test aircraft is pretty well documented, well understood.
So I'm going to take a moment here to talk about what you're seeing kind of at the bottom of the screen there. We're providing you with a bit of the telemetry. Honestly, a small fraction of what's coming off the airplane.
Throttles coming up for fuel burn.
But what you see there is we have the altitude on the, there's a mission time. We'll just run a clock when the airplane takes off. But then we have the altitude. What you're seeing there at 2,700 feet, that is the elevation, above mean sea level that the airfield is at. So XB-1 is starting from an altitude today of 2,700 feet. The Mach 0.1 and then the airspeed that you see there in knots, It's reading right now as having speed because the instrument actually has a minimum amount of, basically pressure that it can detect. So it always holds just a residual value of approximately 65 knots or Mach 0.1. As the aircraft accelerates, you'll start to see those numbers tick up. In Mach, again, you're seeing that in right now. It's Mach 1 is the speed of sound. So every 10th of a Mach is 10% of the speed of sound. Airspeed is in true airspeed, so that is going to be the aircraft speed.
Test control, I show you in band for fuel.
Okay, we're
go brake release.
We're good for fuel.
Copy, go brake release.
And that's the indication that XB-1 is cleared to take off.
1 and 2, you guys set?
Chase 1, 2 ready, go, take off.
Chase 1 set, see ya.
So let's take advantage of this and just watch XB-1 on her takeoff roll as she leaps into the air for the first ever supersonic flight of an independently developed civilian supersonic aircraft. And she's airborne. Wow, that was fantastic. Doesn't she look gorgeous? Especially when the gear's up, she looks an absolutely beautiful airplane. And in the pilot's world, we say that if an aircraft looks right, she'll fly right, and XB-1 certainly looks right. The psychiatrists, in fact, tell us that an aircraft like XB-1 looks great, and we like it because it appeals to both sides of the brain, the left side for its technology and the right side for its stunning good looks. And she's climbing pretty steeply now, Greg. Why is she climbing so steeply as that?
Mike, I mean, I've never had the opportunity to be outside and watch it fly. I've always been in the control room, and it is remarkable how quickly it does indeed climb. XB-1 is designed to be able to climb effectively with a single engine failed or single engine inoperative and the gear down. The gear provide a substantial amount of drag. That's why we pull them up early, getting off the deck, and we have all 3 engines operating. So we have essentially a tremendous amount of excess power. That clean and dry check that you heard right there, that's the chase plane will do an external inspection of the aircraft. And so they're looking at panels and making sure there's no movement, excess movement or flutter on any panels, no leaks or anything like that. So just an external, again, the benefit of having another individual right there next to the airplane able to inspect it from the outside.
So with XB-1 in the air, Greg, what can we expect from this initial phase of the mission before we get to the point where we'll go supersonic?
The initial phase of the mission here, the first card in our test cards here is takeoff and climb out. The whole function of this is to get into the correct airspace at the right speed and the right altitude to really set us up for entry into the supersonic corridor. So the pilot, Geppetto, and the aircraft, they have experience in the control room as well, all have experience with the aircraft during all altitudes up to 32,000 feet and the speeds that we're going to be experiencing at this point. So primarily, they're just evaluating, is the airplane behaving like we expect it to behave, as we've seen it behave in previous missions, and making sure that everything is aligned with expectations. So, Geppetto will be going through. Also, a number of systems will be coming active, and so he'll be looking to make sure that they're performing appropriately. Cabin pressurization is kicking in to pressurize the cockpit. Making sure the temperatures are all good.
Test control, we're ready for a flutter comm check when you are.
And so, and then things like fuel transfer kicking in, making sure there's a number of devices on the flight control system that augment how the flight controls behave. Those go through schedules that are a function of speed and altitude, so we'll be making sure that they're on schedule. So the control room's looking at that. Geppetto's looking at that.
Test flutter, how do you read?
And so what you're hearing here is that there's one person primarily that can speak to the pilot, and that's the test conductor, Aaron Young. When we run a flutter profile, there is a station in the control room.
Test control, I have you in the climb to 34,000 feet. I have card 1 complete. Next up will be card 2, the Mach 1.1 expansion and flutter block.
So and so there's one other station. When you run a flutter profile, you're exciting the aircraft and shaking it. And so they're looking at data, the flutter station. It is only during a flutter profile that is being run that we give the flutter profile the ability to reach out directly to the pilot to tell them to knock it off if they see anything that they don't like. So that's what you just heard there. It's saying as Aaron was saying, there's no other point.
Target test, you did copy. West being active, 2425.
There's no other real function on this card except to get to 34,000 feet.
As you get, we're getting some fantastic shots here, and we can see now as XB-1 is climbing up through 22,000 feet, Mach 0.79, 79% of the speed of sound, which is around about the cruise speed of a conventional airliner, 477 knots. That's true airspeed, of course. So the figure in the middle is the really key one today, 0.81, 81% of the speed of sound. So Greg, tell us a little bit more about what it actually means to go supersonic. What does breaking the sound barrier, why is it so challenging to an aircraft?
Yeah, the sound barrier is a real thing. It's not just some flowery language to describe, this moment of going faster than the speed of sound. As an aircraft flies subsonically, say 30%, 40%, 70% of the speed of sound, the drag characteristics or the resistance of the air that the airplane has to fly through is very predictable. And in the 1940s, as airplanes were kind of getting faster and faster, fighters were going into dives, chasing other aircraft and whatnot, they started to notice this phenomenon where the drag would pick up substantially as they were kind of approaching these higher Mach numbers, 0.8, 0.85, 0.9. And essentially what's happening is that as an airplane flies through the air, it is displacing air, it is manipulating the air, and there are areas as the air kind of transitions from nose to tail where air is being squeezed or compressed and slowed down, and areas where it's being expanded and sped up. And what will happen is that in some of those areas where it's being expanded and sped up, even though the airplane's flying lower than the speed of sound, you can have local areas of supersonic airflow. When you have supersonic airflow and it slows back down, there's a shock wave that forms behind it, and it's what happens, it's the effect of this shock wave.
Control test, you want to verify the test profile?
Test control ready.
The presence.
120-2, start 4, and 65, duration 120.
So it's the presence of these shock waves
confirmed.
and the effect that they have on the air and the airflow over the aircraft that actually creates this rapid rise in drag. And so as an aircraft is accelerating, say from Mach 0.85 to greater than the speed of sound, as you can imagine, more and more air starts to go supersonic. The shock waves are shifting on the aircraft. And even if you are going faster than the speed of sound, you can still have local areas that are slower than the speed of sound, like, the compressed higher pressure areas. And so it's not only until you get kind of well beyond the speed of sound, Mach 10% above the speed of sound is what we're targeting today, when you can get some more fully developed supersonic flow across the aircraft, things clean up, there's less shock waves across the aircraft, and as a result, the drag starts to reduce on the backside of the sound barrier. One more thing to mention here, or a couple more things to mention here actually, is that as those, as you're speeding up, those shock waves are moving across the aircraft. You can see effects, if it goes past a air pressure probe or port, you'll get disturbances in altitude and in airspeed. So do not be surprised if you see some fluctuations in airspeed and altitude as the airplane is going beyond the speed of sound. And then one more thing to mention here is that the engines do not like supersonic airflow. Fundamentally, they're just not really happy with it. And so the reason that the inlets are shaped the way they are, and the way you see this common on fighter jets and other supersonic aircraft, is they actually develop and control these shocks, these supersonic, the shocks that slow the air from supersonic to subsonic, to slow air inside the inlet and to provide the engine with subsonic speeds, even though the aircraft is traveling supersonically. So that's one of the design features. Ways that you make an airplane go, easier break through the sound barrier. One, add more thrust, right? You can always, more power, more better. However, that's not an efficient solution. So some really clever people in the 1940s, 1950s, 1960s discovered that through clever shaping of the aircraft, you can reduce that wave drag. And so a lot of that is why XB-1 is such a long, slender aircraft with a long fuselage, very gently changing features and contours on the aircraft. And the reason for that is again to minimize the disturbance on the minimize the disturbance of the airflow on the airplane and the creation of those shocks. So hopefully that provides some insight as to you know, a lot of the considerations that go into and the effects of you know, breaking the sound barrier.
Greg, that's fantastic. Also fantastic, these amazing air-to-air shots that we're getting. I mean, it's unbelievable that we're kind of looking over Geppetto's shoulder. And I'm glad to see you back with us, Nick. How are we getting these wonderful photographs?
Yeah, that's right, Mike. So actually we have Starlink equipped in our Chase T-38 today. We're using a Starlink mini antenna that we've paired with an aviation data plan. And it's just pretty incredible. It's such a diminutive little device that's been able to, we've done some testing in the T-38, and basically we're getting broadband speeds, you know, at 0.88 Mach, 31,000 feet. It's just the capability that it's brought to the game of flight test has been pretty incredible, actually. Very surprised by the capability. But that's what's enabling these live shots of XB-1 in the air as it prepares to go supersonic.
And we can see XB-1 and the Chase in the turn now, looping around towards the area where we can go supersonic. And XB-1 is a phenomenally high-performing aircraft, and yet it kind of feels that she's not climbing up at full power, which is absolutely the case because she can outperform the Chase aircraft. So Geppetto has had to throttle back a bit just to let the Chase catch up and then to keep station on him. And they're doing that now in the turn. As you can see from the indicators on the screen, 32,000 feet, Mach 0.88, and that's faster than any subsonic aircraft goes. Above that Mach number, when we go supersonic, there will be a little yellow flag pops up to tell us that we're supersonic, but that's just a TV indicator. Greg, how do we know, absolutely know, when XB-1 is supersonic?
Well, that's one of the reasons that we're going all the way to Mach 1.1 today, is to make sure that we're clearing some of those transonic effects that can wreak havoc on.
We believe that was a transient with the debalance on the cast. We think everything's actually okay.
So, and why we're going to 1.1, make sure we make through all these transients that can cause error with the air data sensors, both with altitude and airspeed. We also have.
Yeah, I think they're about to actually issue your go for Excel, so let's listen into the control room comms.
Test control, your go for Excel to Mach 1.1.
Go for Excel, Kestrel Gate.
Kestrel Gate, go for Excel.
So this is the really exciting part. Watch the Mach number in the middle of the screen.
Space 1, full gate.
3 engines and afterburner. Mach number's ticking up.
There we are. XB-1 is supersonic, faster than the speed of sound. We've got confirmation from the control room that she is supersonic. What a wonderful achievement. Geppetto and the whole team know what a really historic moment this is. The first civil aircraft independently constructed that has ever flown supersonic. And Geppetto is the first pilot ever to do it. It is really thrilling moment. And we can see her right now watching it. Nick, how do you feel?
Fantastic. Mike, I've been working on this program for years. Not just me. So many people have poured years worth of effort into this moment, and to just think that this is the first civil supersonic aircraft in American history, I'm to the moon excited about how well that went. We saw the Mach number lingering there a little bit. It kind of paused at 0.97. We actually expected that. We talked about that in this morning's brief, how sometimes the air data doesn't really know what to do with that onset of the shock wave when it actually hits Mach 1. But then it came back at, we saw 0.04, I think, was the first indication. But here we are at Mach 1.1. Airplane looks great, and they're into testing.
Flying supersonically, what's the experience like? Well, from my experience on Concorde, there's absolutely no physical sensation once you're supersonic. There's also no physical sensation of going through the sound barrier. When a plane's traveling at faster than the speed of sound, and today it's up around about 770 miles per hour, you really don't realize it. And yet, today, for instance, XB-1 is traveling so quickly that a distance like that between, say, San Diego and Los Angeles could be covered in just a mere 10 minutes. She's actually flying faster than the Earth rotates. She's going so quickly that the sun is going literally backwards in the sky. It's quite an amazing experience, and yet that's the really clever thing that the aviation engineers succeed in doing, to make the experience so that an aircraft can do all of this while the passengers are just sitting in comfort, and even sometimes they have to put indicators in the cabin to make sure that the customers do know that the aircraft is flying supersonically. So Nick, I mean, tell us a little bit more about what's going on for this stage of the testing.
Yeah, it looks like we're just kind of flying straight and level, but I can tell you there's a flurry of activity happening in the control room right now. The flutter engineers, we just activated what we call the flutter excitation system, and the loads and dynamics team within the control room are looking at the data about how the aircraft structure, when it's vibrated, how it interacts with the airflow on condition supersonic Mach 1.1. So they're actively monitoring that we call it aeroservoelasticity, is the dynamic of the aircraft structure. That's what they're focused on. As soon as that flutter test is complete, we're going to enter a phase that we call a flying qualities, handling qualities block. And that's evaluating how XB-1 is to fly. The flying qualities portion relates to the hands-off behavior of the aircraft. Geppetto will actually disturb the airplane and roll, pitch, and yaw, and then he'll get actively in the loop for the handling qualities block and test what it's like to maneuver.
Yeah, I'll just say right now we've decelerated back from the speed of sound, and the reason I believe that is for airspace considerations, which we only have a limited amount of airspace to work with here, which kind of limits how much testing we can get done on any one pass. So the team will look at some data here and evaluate and see if we want to make another pass to get into those handling qualities evaluations.
Of course, that's one of the issues, that is a very limited piece of airspace available to us, and the aircraft is traveling so quickly, it's quite normal for it to have an issue with going outside the airspace. And of course, Geppetto is fully aware of that, and so he's monitoring where he is and making real-time decisions about how to control the speed of the aircraft to remain within the airspace. So we're not quite sure yet whether we're going to do another acceleration, but the aircraft has gone supersonic, and she was supersonic for just under 4 minutes. Greg, I saw your face when we went through the sound barrier. You must be absolutely thrilled.
I mean, I can't be more excited. Obviously, you know, the mission's not over yet. The real moment of relief and excitement happens when the airplane gets back on the ground. But as Nick said, we've been working on this for a real long time, and we've thought about this moment. This moment has been a motivator for us for years now, and you know, it's just, these are one of those kind of like once, twice, kind of in a career moments if you're lucky. If you're lucky, you get these opportunities, and just incredibly thankful that you know, that we've had the team that we've had and been able to accomplish the things, you know, that got us to this point. And you know, I can see now that we're still at 34,000 feet. We're in the turn. We're heading back to the east, so I anticipate we're going to accelerate again to get some more data here. Would be my anticipation as we discussed in the brief this morning. So watch that
control room
number
there. Yep.
So kind of 2 for the price of 1, really. 2 supersonic flights for the price of 1. And just to see the team, they're absolutely thrilled, we can see here.
I've got to go to the right side for sun.
And there we are, supersonic again.
Knock it off, knock it off, knock it off.
Just going through the sound barrier, pop up to Mach 1.1, and then she'll probably come back down to route back towards the west and back towards home by routing over Edwards Air Force Base and then back to Mojave Sea Air and Spaceport. So Nick, she's come back down through back to subsonic speeds. What happens next?
Yeah, so this was a contingency that we talked about this morning. If we weren't able to get all of those test points done in one supersonic run, we were planning on doing a second one to try to capture all that data that we would like to capture on condition supersonic. So I think that's what they just executed there to get those last test points.
The aircraft is still routing out towards the east, but she'll start a swing round in a moment to come back towards the Sea Air and Spaceport. And the handling characteristics at this stage, from my experience, are amazing, that the aircraft, a supersonic aircraft, can be handled so gently. You probably didn't see any movement on the aircraft when we were going through all those tests, because they are minute movements. I mean, we talk about making tests on the aircraft's handling qualities, but they really are small movements that Geppetto is making, aren't they, Greg?
Yeah, and I do want to acknowledge that we did hear a knock-it-off call from the test conductor. That is not an uncommon call that you hear during the flight test program. We're still up at about 33,000 feet and flying around at Mach 0.9, and then the control room will evaluate whether we want to get more test points today or not. And then obviously at some point we become fuel limited. But yeah, everything is a measured kind of decision on the airplane. And also, the pilot being extremely good at what he does, knows how to handle the aircraft and during these supersonic test evaluations and handling qualities evaluations. So, we got the right people for the job.
Well, I mean, and it is absolutely amazing, historic milestone, or milestones, as we went supersonically twice, because Boom is the first independent company ever to design, build, and fly a supersonic aircraft. And this is a demonstrator to demonstrate Boom's ability to do that. It's a capability demonstrator. And we all believe that innovation in aviation is necessary to get the industry to move forward. The industry has only really gone backwards in time in the last 20 years since Concorde stopped. Historically, the human race has always wanted to go faster. I mean, the horse was domesticated over 6,000 years ago to enable people to chase up their prey or run away from things that are chasing them. That was around about 15 miles an hour. Then ships came along and they got gradually quicker and up to around 25 miles an hour. And then latterly, in the latter parts of the 19th century, trains came along maybe up to around 50 miles an hour. In the early part of the 20th, cars could go up to 70 miles an hour, and then aircraft came along a little bit later than that. Initially 100 miles an hour, then the jet took it up to 400, then jet airliners to 650, and now we have supersonic aircraft that will be the forerunner for the Overture supersonic airliner that will be going up to Mach 1.7, twice as fast as a conventional airplane. That's the vision of Boom, and that's the objective of all of this activity, and I'm absolutely thrilled to see a civil aircraft flying supersonically once more. Greg, it's incredible to see this milestone after working on it for 8 years. I know how involved you are in the program. Really, how does it feel now to see the airplane turning and starting to route back towards Mojave?
Again, just fantastic. Like I said before, the mission's not over until the airplane's safely on the ground, but this is such a huge step, building the first civil supersonic jet, right here in America. This jet really does have much of the enabling technologies that are going to enable us to go ahead and build a commercial supersonic airliner that is available to the masses. This is like this test specifically, this day today, we were able to collect a bunch of high quality data, and that data goes directly into the tools that were developed for the design, for the development, and for the evaluation of the performance and handling qualities of XB-1. It's those same tools that sort of graduate over to the commercial development effort, but now we actually have data that we can use to anchor those tools, calibrate those tools just that bit more, and make sure that we're getting high quality predictions. And that's what enables us to rapidly iterate on the design and really tune the design of that commercial vehicle, making sure that we are going down a path of economically viable, environmentally viable supersonic travel in the future. And so just, this is what it's all about. This is why we did this program, was to come out here and have a day like today and get this data.
So the aircraft's right out to the east now, making that turn to start heading back towards Mojave. Nick, we've got this extra second supersonic run and an extra return to base point. Are there any extra tests that can be put in during this, or are we just now recovering the aircraft and waiting until the accolades for what really is a historic achievement?
Yeah, I think right now, Mike, it's all about coming home and getting return to base. We call it RTB. So that's what Geppetto's focusing on right now.
I actually say it looks like we're in AB at Mach 0.96 and 34,000 feet. This is an indication to me that we are going supersonic again once more on the heading to the southwest, back into that corridor. So very much along the same line as our first supersonic run. An indication to supersonic. We are now supersonic 3 times on this flight, which is quite unbelievable. And it's great. We have the fuel for it. So we're out there, and again, the objective here is to get the data, and that's what the team's doing.
You sure it's not just Geppetto having a great day out there?
I mean, I'm sure Geppetto's having a great day out there. It's interesting because I know that Geppetto's been supersonic a lot of times in his life and in his experience with the F-18s. F-5s that he flies for Navy aggressor squadrons, etc. But I can promise you, no time has been more special than today. And I'm pretty sure he didn't expect to get three cracks at it.
Yeah, so Mike, when I was out there at the fence line, I just took a moment just for me. I just watched it take off, because every time that we've flown to date, I've been in the control room looking at data. So I had like myself a little Anakin Skywalker moment there. Let me look upon you with my own eyes, and it was truly emotional just to see the airplane fly for the first time. I'm to the moon that it's going well enough that they've elected to do a third run and clean up all the data points.
And it looks like they're in the handling qualities evaluations now. There's a little bit of maneuvering going on. You can see this would be indicative sort of a roll step. You want to evaluate in the handling qualities evaluations all three axes, so there'll be a pitch input, and really what this is to see how the aircraft, you put a disturbance in it and how does it settle out, and a lot of the predictions that go into this and the tools that we have. It's a lot about the flying dynamics of the aircraft. If some of you are wondering, like, we're in afterburner, it's like, why is the aircraft, and now you can see we're out of afterburner and start to decel here a little bit.
Would you application?
Sorry, I'm off condition already.
And so it may be a question.
Let's wrap it up and head on home.
If you're in,
Chase 1.
so it sounds like we're good. That's it right there. Head home. So we're going to start to decelerate and descend. But you may be wondering, hey, if you're in afterburner, why? How are you holding at Mach 1.1?
In test control, you're good for descent and recovery.
And so,
Coming down.
and so, how are you good? Holding at Mach 1.1. An interesting thing about
Test control at
afterburners.
card 3 complete. Next up is card 4 recovery and return to base.
There it is.
Copy.
So that's
Now we're done.
yeah.
Well, we're done when we land. Yeah.
Science collected, science performed, data collected, run away back home. But interesting about afterburners is there's a min afterburner all the way through to max afterburner. So you can throttle in afterburner as well. So Geppetto was actually in approximately min afterburner. There was a chance that maybe a little bit above, but that was something, again, with the performance predictions that we have. You're not really sure until you get there how much, where you are going to be with that thrust demand for the engines to hold condition. So we're going to descend. We descend quickly. When Geppetto was climbing out, the airplane was climbing at more than a mile of vertical altitude per minute. So it was somewhere between, about 5,500 feet per minute to all the way to 7,000 feet per minute in the climb out. He's going to descend pretty rapidly, too. So they come down pretty quick.
Give me a couple, Jeff, please, on idle ports.
And so, and again, it's about
He's asking if we're going to Mojave or...
managing airspace. So.
Yeah, and Greg, actually, we've seen on earlier test flights, if you remember, XB-1 actually outclimbed a T-38.
Yeah.
XB-1 had its gear down. The T-38 had its gear up, and XB-1 outclimbed it.
Yeah.
So XB-1 is a performant airplane, and it's just been the highlight of my career to participate in this flight test program. It's such a cool aircraft.
And of course, that's why I consider it Geppetto throttled back a bit on the climb so the other two aircraft could keep up with him.
Absolutely.
That's not an issue going down, of course. And as you can see, we're on the way down, coming down through 22,000 feet. Greg, you mentioned Geppetto's experience. I believe he's had about 200 carrier landings. And in a carrier landing, of course, there's also a chap or a lady that stands on the carrier and gives you landing directions. Now, I believe we're going to use that later on today. So, do you want to take this opportunity just to highlight what that's all about?
Yeah, so in the Navy, they have an individual that stands on the back of the ship called the LSO, or Landing Signal Officer. And this has been employed since the early days of aircraft carriers and still is used today. That individual will help talk a pilot down to the landing point. And in this case, we have an individual who's going to be standing next to the runway, basically right a beam of the touchdown point. And what they'll do is they'll give verbal feedback to the pilot,
We're going to start a right turn here.
both about altitude. So on glide slope, if you're above glide
Test
slope,
control
below glide
reminder,
slope.
reset altimeter 3005.
And then if you are left or right of center line. So those are the kinds of calls you hear. When the pilot makes contact with the LSO is called paddles. That is because back in the day they used physical paddles to give these sort of visual indications as well. And so they'll make contact. They will have exclusive use of the comms. The pilot, you'll hear him relay in numbers. It might be something like saying 1.8 on initial contact. That is the aircraft's fuel state. That gives paddles information about, do I need to get the airplane down on the ground now, or do we have a go around? Can I wave them off if something's slightly off nominal, etc. And then they'll talk them down. That's not the only landing aid. The primary landing aid that we have on this aircraft is a forward-looking vision system. And so you know, back in the day, your day, Mike, on Concorde, you guys had to have that droop.
Altimeter is reset 3005.
You had to have that droop nose in the visor so that the pilots could
Make it
physically.
360 here, and that'll set us up for a straight in.
Sorry, please. So if we could physically see the runway, you know, and have visual contact with the runway, because you know XB-1, much like the Concorde, when flying on approach at slow speeds, they're very nose high, even though they're descending. So that nose is sort of in the way and blocks the runway. So we actually have 2 cameras on the nose gear. So when the gear come down, the pilot will have the use of these cameras. The cameras are purely redundant. So if there's any, you know, we have an issue, if there was a, you know, in the way off chance that we ever had a bird strike, if one of them hit a camera, we'd have a second camera there that the pilot could utilize. And so basically, if Geppetto on approach could see through the airplane, he would naturally be looking down through his multifunction display, and that's where the camera displays. And so he is actually flying on a video screen.
We expect the fuel low momentarily continue.
And that is one of the that is one of the technologies that will carry over to the Overture aircraft as well. Cuts out a lot of weight, a lot of complexity with having a giant mechanism just to move a nose. Now we have high resolution displays and small cameras. So
of 170.
Thanks, Greg. Nick, we just heard the control saying we had a fuel low warning. What exactly does that mean?
Yeah, so that's just an indication that he's on the last remaining fuel tank. So there are 5 fuel tanks in XB-1, and this is expected. This is par for the course. But he's on his main tank, which is the largest tank in XB-1. It holds the most amount of fuel. And he's burned the peripheral tanks, and this is the tank that we typically land on. We like to be on that main tank with approximately less than 2,000 pounds of fuel for landing. XB-1 can land heavier than that, but it's just it's more load on the gear. More energy gets put into the brakes when we land heavy. So it looks as if we're at the sweet spot actually for landing.
So we're actually managing the flight to ensure that we don't land with too much fuel.
That's right. Yeah.
Okay. And you'll see when XB-1's on final approach just how nose up she is. Of course, there's also the conventional instrument landing system that'll help Geppetto, but what's going through his mind right now, I wonder? Well, I kind of guess he won't be thinking too much about the excitement of 3 supersonic dashes. He will be later. He'll be concentrating now on getting the aircraft lined up on the center line on the correct descent path. Now, you can see from the digits in front of you, we're just going down through 6,000 feet, bearing in mind that Mojave is 2,800 feet up. So we're really just about 3,000 feet above the ground, slowing right down into final approach speeds. And of course, accompanied still by the 2 aircraft accompanying the chase aircraft, and that's what's giving these wonderful pictures. And I guess it won't be long until we see the gear coming down.
Standby gear.
Here it comes.
There it is.
3, 2, 1, mark.
So that's the mark for Geppetto to select the undercarriage down. Here she comes.
And we'll get verification from both Geppetto and the control room here.
Lock, dampers on, fuel systems auto, anti-skids auto, 170.
That's the landing
Control.
checklist that they just completed.
Yep.
Looks like good gear, Mike. As a landing gear designer, my heart melts every time I see that gear come out. I think it's beautiful.
And this is a really special landing gear, isn't it?
It is. It's bespoke for XB-1. It was a custom gear.
Yeah. It's
So we're probably about a 6 mile from landing now. I would expect that LSO to take over the comms here momentarily, and that'll be exciting to listen to. So let's listen into the LSO comms.
Yeah, I just want to mention we have 2 LSOs who have supported us on this mission. Zach Pleiss, call sign Sprite, again a former naval aviator, and Charles Wickware, call sign Wignut. I believe we're going to hear Charles on the comms today, would be my guess. But both of them are here today. It's a big flight, and obviously, we all want to be a part of it. So what we'll be listening for is Paddle's contact in a very nice, calm, friendly voice.
And then you'll hear Paddles giving advice to Geppetto about being on glide path, on center line, or maybe even slightly above, or slightly below, or slightly left, or slightly right. And Geppetto's got enough experience flying XB-1 and the XB-1 simulator. He's got many, many hours.
Hundreds of landings.
Yeah.
Yeah.
So he'll be really familiar with this. So it's just an additional piece of assistance for him to get the right approach path and the right speeds.
XB-1 is a test aircraft, and so this is a brand new system. There it is. We'll listen in.
Headwind 7 knots. Strong glide slope, strong center line.
Test 1.8.
So you have glide slope centerline and test given the 1.8 fuel call. And you can see there like a difference between the angle of attack of XB-1 versus the the Mirage next to it.
A little high coming down on center line.
Like those airplanes are flying the same speed, both in the same descent, and one of them is substantially nose up.
High coming down on center line.
That high angle of attack, a characteristic of the Yogive Delta wing. Concorde had a high landing angle of attack.
Very similar to that.
Approaching glide slope, you're on center line. There's glide slope, you're on center line. On glide slope, on center line. On glide slope, on center line, 50 feet. On center line, 40. On center line, 30. 20, 10, 5, 3.
And she's down right on the numbers. Absolutely beautiful. Right on the numbers, right on the center line. And I'm going to turn around and watch her roll out down the runway. What a beautiful sight, and what a really successful day.
Good brakes.
Awesome. Getting a little bit of a flyby from the T-38 and the Mirage F1. And so XB-1, yeah, we'll continue the rollout down the runway here. You heard the good brakes call, which always gives Nick a bit of relief, being the brakes guy at one point in time. But Geppetto will take it really easy. He'll roll it down the runway and just let the speed bleed. But we do have to clear the runway because we have two other aircraft to recover here. Both of the chase planes expect to be landing here.
And of course, things aren't over yet. Although we're landed, there's still quite a bit to do, isn't there?
That's right. And so we heard the call out there briefly before Geppetto was getting configured for the landing of approach speed of 170. We actually update that. Given the weight of the aircraft, there's a different speed that we land at, and so the control room will back Geppetto up on that. I mean, he greased it on. Geppetto has made it look easy every single time he's landed. This is his 11th landing. In the real XB-1, of course, hundreds of landings in the simulator to prepare for it. So Geppetto's going to roll to the end of the runway, and he's going to turn left onto taxiway Alpha and come back, and he should actually park right behind us here at this desk, maybe about 5 minutes from now or so. After that, there's a standard checklist that he'll execute to safely and properly shut down the airplane. And after that, you'll see the crew chief, Kurt, will probably, and his team will swarm the aircraft, perform a series of inspections on the airplane, make sure everything looks good. You'll also see somebody connect a data cable, an Ethernet cable, right in there to the side of the airplane. And that's the most important part right there. You know, after the safe landing is assured, it's all about, you know, show me the data. We just collected some really valuable data, and I can't wait to get my hands on that data. The entire control room team is going to spend several days poring over the data that we collected here during today's flight, and they're going to be checking the actual performance that was demonstrated against what our models predicted and how we expected it to fly. And it's really the confirmation of our tools that enabled us to predict the performance of a supersonic airplane, validated against actual flight test data. That's the whole point of doing flight tests right there, is to prove that your ability to design and build and predict how an aircraft is going to perform, that's actually true. And so we've got our litmus test here today, our proof data that we'll use to inform future efforts on Overture.
And of course, in the airline world, after you've landed, it's important to get to the terminal as quickly as possible, get your customers disembarked. You don't want to be wasting time, but it's not quite like that today, is it, Greg?
No.
I mean, for a start, we've got to get down to a minimum fuel, but there are other things that need to be done.
Yeah, and so we choose to get down to a minimum fuel. It makes it easier on the maintainers. Makes it easier to turn the airplane around. But yeah, again, like we say, we go through this checklist just like we do prior to flight and in the pre-flight and even in flight. There is an after-landing checklist, and as Nick said, it's just about making sure the airplane is properly configured so we can do the things that we need to do and really get this airplane turned around in short order for our next mission, which, you know, hopefully will be, you know, if we don't see anything that needs to be rectified or adjusted on the airplane, this is, you know, we could expect maybe a next mission in the next 10 days or so. Nick, do you have any more information on that?
Yeah, so this is not planned to be XB-1's last flight. We've got another flight coming up where we'll go supersonic again, and that might happen as shortly as about a week from now or so. And we're planning something special on that flight as well, too. We've demonstrated that XB-1 can be safely operated at at supersonic speed. Our data review process will confirm that after we've checked everything. And then what we're actually planning to do is to get some really spectacular imagery of an aircraft in supersonic flight. The details will be announced on that pretty soon, but what we're looking to do is actually capture some special type of photography called Schlieren imagery, and that allows us to actually visualize the shock waves that are coming off of XB-1 while it's supersonic. That's what's in store for our next flight.
And you can see the video pictures of XB-1 taxiing in, and we can hear her here.
Yep.
And shortly we'll be able to see her coming in, and here she comes. Let's just watch XB-1 taxiing in. And Geppetto's parked her right on the numbers, right outside the hangar here. And as you can see, or we can see here, people are gathering the cameras, video cameras. They're all coming back from the park line where they were watching the flight. A drone flying past the aircraft to give really good views of the whole aircraft. And I think I actually caught a smile there from Geppetto at that very moment.
And you can see the ground crew just getting to work, you know, immediately, securing the aircraft. Again, we want to maintain this as a healthy test asset, obviously. They'll do another inspection. So engines are off right now, mercifully. A little bit quiet out here, but you know, they're going to do a walk around of the aircraft to make sure, see if there's anything that they need to get a start on before the next mission. And yeah, they're underway over there. I think this actually is going to conclude my portion of the broadcast, but I do want to. I have a couple of thank yous that I want to say first. Mike, incredibly appreciative of you coming out and spending your time with us here today and participating in this event. But not only that, obviously you've been an advocate for this mission and a friend of this company for an extremely long time. And you've been super helpful in just, you've given your time to us, and I can't thank you enough for your participation. I also want to thank Blake. Obviously, without Blake giving us the opportunity, trusting in us to do this mission, none of this would be possible. And so I wouldn't be here today if it wasn't for Blake Scholl and Boom Supersonic. So incredibly thankful for, again, like I said, his trust in us and providing us this opportunity to go out and do what we did today. I want to thank a whole bunch of folks who participated in this program. We've been working on this plane for a long time, and there's members of the team who made significant contributions to the aircraft who are not able to join us today. And I really just truly want to say thank you to them, and I hope that they understand the impact that they've had and can feel a part of the success and celebration that we're going to have here. And then lastly, it's been a long time. We've had a lot of families who have had members of those families out here in Mojave supporting flight tests for the past year and a half. And I know it's been hard for those families, and I'm so thankful that they've been able to support our crew and kind of, keep things together while we've been out here chasing our dreams. And again, I'm just incredibly appreciative of them, and they have as much credit and success in this as we do. So just want to thank all those families of our crew members here today.
Well,
thank you, everyone.
Oh, thanks very much indeed, Greg. I know how heartfelt that is. I'm just being here for a few days this week, seeing the bonding between the teams and how really proud you are and how really proud they all are of what's been achieved today. It is a wonderful team achievement and a great pathway to Overture aircraft. Overture, the planned supersonic airliner of the future. and it's planned that she will be rolled. The super factory that's in North Carolina is already built, and we'll start moving towards launching of the aircraft in around about 18 months' time. The engine to power it is scheduled to be run for the first time this year, and we're on a real strong pathway to a supersonic airliner returning to service. It's really important to me and to so many people that we make steps forward in aviation, not steps backwards. It's been a long time since we had to say we can't do that anymore, and I can see on the horizon an opportunity for everybody to travel on supersonic aircraft on Overture again. It makes the world smaller, it brings people together, it halves flight times. New York to Paris in just under 4 hours, London to Washington 4 hours and, well, instead of 8. And they're just 2 examples. There are more than 600 supersonically viable routes around the world that airlines can profitably fly. And because of that, Boom already have orders and pre-orders for 130 aircraft from airlines like United Airlines, American Airlines, and Japan. And that super factory's already completed in North Carolina. So the future of supersonic travel is looking incredibly promising. We really will connect cultures, countries, and people across the world together, making long-haul transoceanic travel faster, more accessible. It's not just about speed, it's about making the world more connected. So I'm on my own here because the other 2 guys have left. They're out on the ramp. Let's have a look behind us and see whether Geppetto is coming down the steps, and yes, he is. So let's watch him deplane and then hand over to Nick out on the ramp.
And there's that moment. I don't know if you can hear me on the mic, but Geppetto just stepped out of the cockpit, getting that hero shot there, coming down the ramp. And our CEO, Blake Scholl, is about to meet Geppetto and shake hands after a successful mission.
No, had to do it. Had to get 3 of them in there for you.
Yeah. Congratulations, you are the fastest civil pilot alive.
Well, thanks, Blake. Thanks for putting together this incredible team who built an incredible aircraft. She was real happy supersonic, and that's the best she's ever flown was supersonic.
Awesome. Well, congratulations and well done. Thank you.
Thank you.
Cheers. Cheers. To many booms to come. So, a little bit slower over there. Today's a day that I've been looking forward to for more than a decade, and it makes me so proud of this team, so proud of this country. America is the only place where a relatively small band of people can decide to do something and just go do it. And today we did. This afternoon we get to celebrate. Tomorrow we're back to work because it's time to go big. It's time to take this little airplane made out of airliner technology and scale it up. It's time to bring supersonic flight back. It's time to bring it back for all of us. It's time to bring it back in a mainstream way. And we're not going to stop. We're not going to stop until everyone can benefit from this. From the president to every family, to make the world a smaller place, to bring humanity closer together. Let's make America boom again. Thank you very much. Cheers. Please join me in thanking the remarkably small group of men and women that have been working tirelessly to make this happen. There are many, many days along the way where reasonable people who cared less would have given up. Many days where there were problems we didn't know how we'd get our way through. but we kept going, and that's why we're here today, and we're going to keep going, and that's how we get there tomorrow. And I would like to give just a special thanks to Geppetto. Everyone in this program has been committed and invested in the outcome, but there's a reason history remembers test pilots. Because you had the courage to get in the seat and to take an airplane to a place in the flight envelope had never gone before. So thank you. Thank you for taking that risk. Thank you for giving everything you've got for the future of flight. Thank you, Geppetto, and cheers.
For those of you joining us, my name's Mike Bannister. I used to be the British Airways chief pilot for Concorde, flying supersonically for 22 years. So I kind of got a feeling about what's been going on today. But before we get into this Q&A session, will you join me in welcoming to the stage Geppetto and Blake, who've made all of this happen? Well done. Fantastic, guys. Up here with me, Blake Scholl, the founder and CEO of Boom Supersonic, and Geppetto, who flew the aircraft today. So the dead simple question to start up with, Geppetto, is how do you feel?
Well, I'm not sure my brain's fully caught up with me yet. I think it might still be flying supersonic. A little bit shaky, just excited to be here and grateful to be a part of this team.
And you enjoyed it so much you had 3 goes.
Yeah, that was a contingency that we had briefed. If we didn't get everything we needed on one supersonic run, then we briefed that we'd be able to turn around and do it again. So I don't think anyone in the control room was surprised. It wasn't exactly the plan, but we had it was a backup plan.
And Blake, this has been your brainchild. It's been your baby for the last 10 or more years. How does it feel to see this coming to fruition right now, right here?
It's a little surreal, if I'm being honest. I think it's still sinking in. There were so many days on the road to today where it wasn't obvious that we would get here, and here we are. And I just feel really proud, feel really grateful, and I feel really determined that we're going to keep doing this until supersonic flight's way less exciting because it's just the normal way we fly.
Geppetto, back to you. When I was in amongst the crowd just now, one of the people out there asked me, how does it feel to fly supersonic? So how does it feel to fly supersonically 3 times in one go?
Well, it's always exciting. There's something special about going faster than the speed of sound. I'm sure you remember your first time going supersonic, right? It was probably in an airplane that had done it before. Yeah, so so was mine. But I remember that feeling like as I was getting ready to push the throttles up for the first time in an F-18 Super Hornet, and like it felt like I was climbing up a roller coaster. Like I know I'm going to be okay. Like my brain knows I'm going to be okay, but am I really going to be okay? Is everything really going to be okay? So push the throttles up, and then you see the Mach number finally tick over to Mach 1, and you're like, well, is that it? Is that really all there is to it? Today was a little bit different than that. This was the first time that the airplane had never done it before, and certainly our models and our data had indicated that it was going to be safe, it was going to be predictable, and it was going to be easy. But you don't really know until you push the throttles up and you go for it. Today I was pleasantly surprised that it was actually safe and easy and predictable. I'm sorry, I was not surprised that it was safe. There was no doubt in my mind that was going to be the case, but it was smooth, it was predictable, and it felt great.
If I remember what you said yesterday, you said you were more nervous about the press conference than the flight.
100%, yes.
Quite rightly. I was very jealous thinking of you flying the aircraft because it was absolutely fantastic. But to put it in context, we talk about the first supersonic flight of XB-1, but Geppetto is the first pilot ever to fly an independently developed civilian aircraft supersonically. This just has never happened before.
Well, thank you, Mike. If I could just point out that this isn't my milestone. This is the team's milestone. Like everyone at the company, Blake having the courage to actually make this happen, to put yourself out there and start a company with this seemingly impossible goal. But everyone from Jordan Rosas, who kept us fed and happy, and Steve Graziano, who installed all the rivets. And especially even Doc Shoemaker, who built this incredible culture of safety and flight test. This is everyone's milestone. I was just lucky to be the one to push the throttles up.
I've been lucky enough to be close to Boom for some time now. One thing that strikes me, Blake, is your ability to gather around you all the right people, the key real experts in every field. Tell us something about that, how you do it, and how you've got this sensational team working for you and with you.
So if I think back to the earliest days of starting the company, I would tell people that I wanted to build a supersonic jet, and I could always tell the first question was, and people don't always say it out loud, but the first question was always, are you crazy? And if I could convince people that the answer was just maybe no, then the next question was, how do I get involved and help? And I think the mission is what really makes this possible. The world needs supersonic flight. Passengers deserve it. Airlines need an alternative that's better. America needs to build the next generation of airplanes. And the significance of the mission is what causes great people to come and be part of this. Whether it's the Geppetto and Doc, who flew the airplane for the first time, to the engineers that designed it, the technicians that put it together, the investors that did what their peers said was crazy and backed us, to the airlines like United, who put a deposit down before we'd even flown XB-1, and American and Japan Airlines, who was the first airline to back us. And why? It's because everybody wants supersonic flight. And it's not easy, but it is possible. And if we gather just the very best people in the world, we can do it.
And of course, there have been so many naysayers who say it can't be done. But you guys have proved, and your team have proved today, that it can be done. So, Geppetto, when you're flying the airplane, how much goes through your mind about how this really is a step forward to the future, to the next big step forward with Overture? Is this part of your consideration?
While I'm flying the airplane, certainly not. This is flight test. You know, there's too much going on. I'm just very focused on what the airplane is telling me, working with the control room. Like, am I doing what I'm supposed to be doing? Managing the fuel, managing the airspace, and just making sure that we have a successful event. None of that's going through my head during while we're flying.
But after you fly, after you've flown, I guess you think about it. We were talking earlier on the broadcast about this is not the last flight of XB-1. What are the plans for the next flight, Geppetto?
Well, we're planning on flying it one more time, and the next flight obviously will be supersonic. And we're working with NASA on something that I'm pretty excited about, which should hopefully produce some pretty exciting imagery.
And Blake, the next steps for Boom Supersonic. Tell us a little bit more about Overture in the detail and Symphony, the engine.
Yeah, well, it's what we have that's so special in XB-1 is a supersonic jet made out of airliner technology. And I think one of the things that surprises people the most is we really didn't invent anything. This is really 20-year-old 787 level technology deployed in service of a different goal. And we started out with kind of a sketch of Overture. We didn't even know it was called Overture yet. And the one thing we knew for certain is we didn't have it quite right, and we didn't know everything we needed to know to pull it off. So we shrank down to 1/3 scale, and we said, let's go build design, build, fly, and learn, and then take all those learnings and turn our attention back to the big airplane that we all get to fly on, and that's what Overture is. And so after next week's final flight of XB-1, our attention goes back on that Overture airplane, and so we will be advancing that. You know, where we are today, it's just about time to quote unquote break the engineer's pencils, meaning we have a design that accomplishes what we need to accomplish, and it's ready, we're going to go take it into production. So the next things we get to look forward to, the Symphony engine, and that's our engine that powers Overture. It is the first purpose-built engine for civilian supersonic flight. Concorde, of course, had a military engine that was sort of adapted. This is brand new engine, not a brand new kind of engine, but a brand new engine. The first prototype of that will run later this year, and we're about 18 months away from starting to physically build the first Overture. And our goal is to roll it off the line in about 3 years and put it in the skies in about 4.
Fantastic. It's in the skies in about 4 years, ladies and gentlemen, to see a wonderful Symphony aircraft taking to the skies. And Geppetto, are you looking forward to that moment?
Yeah, very much. Like, XB-1 was the proof that we could do it. We've proven we can do it, but this doesn't change anyone's life. The Overture is going to make the world more accessible. It's going to make connections that wouldn't otherwise be possible. And so that's what I'm really excited about, and getting that aircraft into service so we can achieve our ultimate goal of making the world dramatically more accessible.
Let's get back to talking pilot things. I mean, put your mind back to flying the airplane today. You've got a lot of experience. Tell us about XB-1 compared to the other aircraft that you've flown.
I think maybe the best way to explain this to some of my Navy buddies is this is the closest thing to flying off the boat that there is to flying off the boat. And what I mean by that is once it gets off the ground, it's easy. It's getting it back on the ground that's the challenge. So once I took off, you know, I'm kind of in my happy place. And when she was supersonic, that was the smoothest, like best flying that she's flown yet. Like supersonic flight was really her happy place. She really liked it there, and it was a real dream to fly XB-1 supersonic. Landing is always a bit of a challenge, and today was no exception. Landing off the forward-looking vision system or our augmented reality system, something I practice a lot in the simulator, and I'm grateful to Zach Pleiss, Wingnut, and Charles Wickware, Zach Pleiss, Sprite, and Charles Wickware, Wingnut, as our landing signal officers who help me get back on ground every single time safely.
Well, we could see from the outside, and you got it absolutely on the numbers, in right place, right time, bang on the center line. So what a great job for you and all those around you. Blake, you touched on the future. There have been a lot of naysayers about the future of supersonic aircraft, and yet you're convincing people that it's doable, and you're convincing people that it will happen, and you've got now this demonstration of your capability. How do you continue to convince people that this is the future?
We just need to keep doing it. You know, there's always going to be naysayers, and but they don't make the future. We get to choose to do that, and I think that the history of flight is just such a poignant example of how that really works. You know, of course, the first airplane was built by bicycle entrepreneurs. In no way, shape, or form were the favored team or had the resume to do this. And you know, and shortly before they did, you know, the naysayers were saying it'd be 1,000,000 years before we ever had an airplane. But they pulled it off, and then we had a half a century of just really steady progress and speed. We had Concorde, and then we kind of lost our way. And the future, you know, the future is not automatically better. Somebody has to make it better. And I think, and that's why I'm grateful for the opportunity, for the team, for the support. And success is absolutely not guaranteed. Overture is very, very much harder than what we flew today. And it will not be a straight line path from here to success. There'll be twists and turns, there'll be setbacks. It's virtually guaranteed. But the important thing is not giving up. And maybe one day we'll have a skeptics flight across the Atlantic.
And would you like to compare for us your philosophy within Boom Supersonic about how to go about building exciting airplanes compared to the legacy major aircraft manufacturers that are out there right now? Do you do it the same way, or do you do it differently?
We think we should do it faster and better. You know, in the 40s, 50s, 60s, you know, airplanes were developed very, very rapidly compared to what they are today. And yet today we have better technology and better tools than ever before. And yet the safety bar has come way up. And you know, I think it's our job to figure out how to move fast while also staying safe. And we've learned a lot on the XB-1 program about how to do that. About how to build a culture of safety, but also what other things go into the process that cause us to be slow or enable us to move fast. And you know, it's easy to look at XB-1 and see you know, a beautiful airplane. I look at it and I see a lot of lessons learned, not just the technology of the airplane, but how we went about it. And you know, I believe small, mighty, vertically integrated teams can do things that the big guys wouldn't even attempt. And that's our future.
We're coming towards the end of our Q&A, so I'm going to ask the same question of both of you. I'll ask you to answer it in turn, not together. For the people here, and there's a wonderful crowd here of great supporters who've been really enthusiastic, and the people all over the world that are watching on live stream, what one memory would you like them to take away from today? Geppetto.
I'm sorry, I need a second to think about that. Maybe.
Okay, Blake.
Oh, I was really glad you asked him first. I don't know if it's about today exactly for me. It's been 10 years to get here, and if I could, if there's any one thing I could just share with the world, it would be to work on the biggest, most important things you can always work on, and whatever you do, don't give up. And if you do that, then you get to have days like today.
Thanks. Geppetto?
I think that what I will remember and what I hope other people take away from this is that what a small team of really dedicated people can make happen.
Fantastic. Ladies and gentlemen, Geppetto and Blake.
Thank you, Mike.
Thank you very much indeed for joining us, those who are here, and for those that have joined us on live stream to witness the first American civil supersonic jet break the sound barrier and the first civilian independently produced jet ever to go faster than the speed of sound. Ladies and gentlemen, Boom Supersonic and the XB-1. Thanks very much, everyone. That's really kind of you. Appreciate it. We signed out of our live webcast.